All right. Hi, everybody. We're here with Dr. Granoff, and we are still talking statistics. But specifically right now, we're going to talk about the strength of the relationship and what that means and what that looks like. So, Dr. Granoff, what do we mean?
Well, there's a couple different ways it's expressed. It's usually some sort of an effect size. It could be a correlation coefficient. It could be, if you're doing a chi-square test, you're using a Kramer's V statistic.
Okay.
If you're doing a t-test or a one-way ANOVA, you're looking at an eta coefficient, ETA. And they're all basically the same thing. A rule of thumb came about. Jacob Cohen, he wrote a book in 1988, which said a weak correlation is about 0.10 or minus 0.10.
Okay, so positive or negative correlation, right?
Right.
Okay.
A moderate correlation is about 0.30 or minus 0.30. That's a weak. I'm sorry, that's a moderate correlation. A strong correlation is about 0.50. So weak, moderate, strong, 0.10, 0.30, 0.50.
Okay.
Now, what's more important than the correlation is the square of the correlation. So if a correlation is 0.10, 0.10 times 0.10 is 0.01. So R squared would be 0.01 or 1%.
Okay.
So what that's saying is that's what's called the coefficient of determination.
Okay.
And if you did a Google search on the words coefficient of determination, they would say the strength, or I'm sorry, the percentage of variance accounted for. Now,
Okay.
I like to replace the word variance with the word reasons. Percent of reasons accounted for. So if it's 1% explaining power, that means there's 1% of the reasons are shared between the two variables, or 99% are due to other factors.
Interesting. So not a strong relationship.
It's a very weak relationship. Yeah. If you have findings that are with a R squared of 1%, you probably don't want to get the brass band out and march down Main Street.
Right.
Okay?
Right.
Moderate strength correlation of 0.30, 0.30 times 0.30 is 0.09 or 9% explaining power.
Okay.
Strong correlation of 0.50, 0.50 times 0.50 is 0.25 or 25% explaining power. So this becomes our, for lack of a better word, our honesty statistic. Because something can be statistically significant, but if it's only got 3% explaining power, you don't want to make some big famous, things in your discussion chapter about how you've now, saved the world and you should get a Nobel Peace Prize or something.
Right.
So it helps with the humility to know, because, it could be statistically significant, but probably not educationally relevant. And then you go, well, what's educationally relevant? Well, I'd like it to be at least a effect of 0.30, 9% explaining power. If you've got a variable that, explains 9% of the reasons, that's pretty good.
Yeah. But then it also shows that there's more to know about what affects this relationship, because there's other
factors involved.
Interesting. Okay. I like that you said that you pointed out you can have a statistically significant relationship, but the strength of the relationship is also something you need to look at, because while it might be significant, it may not be, I don't want to say important, but groundbreaking is maybe the word to use.
This is particularly true if you have a large sample. Sometimes what happens is the analysis is overpowered, meaning that you have a lot more people than you need to find the pattern.
Interesting.
Just as a quick review of power, I like to think of power like power of a microscope.
Okay.
Is the study strong enough to find the pattern if it's actually there? So if you've got a sample of 1,000 people, almost everything is statistically significant, even though the amount of variance accounted for might only be 1 or 2%.
Interesting.
So what happens sometimes is, oh, we have significance here. Let's alert the New York Times or something here. No, you need to look at the strength of the relationship. And even the APA manual says, not only do you want to look at the p-value, but you also want to look at some measure of the strength of the relationship.
Very interesting. So the whole idea of a bigger sample size is good is not necessarily always the case.
Yes.
Very cool. Good stuff.